So I'm going to pass and say we're going to get ready in just a few moments to start with the advanced pipe player. First, how many of you used the pipe player last year to run your show? It's an amazing device. I made a post in, I think, July of 2013, the most amazing thing I've ever seen, the Falcon pipe player. Originally created by Dave 2.5 years ago, and then he handed it off to Chris. And as soon as they finish their setup, they'll get started. But I probably consider this the most amazing thing that's in our industry. Of everything I've touched, it's way more cooler than I think X-Lights and all that stuff. So I'm looking forward to Chris ready to wow us.
Wow.
We have way too much fun.
I'm not going to use the mic. If anybody can't hear me, just ask me to speak up, if that's okay. Hopefully my voice will last.
Speak up.
We've been. If anybody but Sean cannot hear me, let me know. So this class is targeted more at more advanced usage of the Falcon player. Yesterday we had the beginner class. We've also had another repeat of that in the room over there earlier on Thursday. So I wanted to deeper dive into a few more of the topics that I brought up yesterday. There was an advanced slide where I kind of breezed through some of the more advanced topics, and we're going to go take a little bit deeper dive into some of those just to explain more about some of them, whether it's for larger shows or just more advanced shows with some interaction. Some of the things that you can do in the Falcon player to get more input or output from the box. So the first thing that I wanted to mention, which sorry about the data being cut off, is something that Sean mentioned earlier, called what I'm calling virtual matrix. So something that we added to the Falcon player just a few months ago, which will be in the next release, is the ability to treat your HDMI output on the Pi as a virtual matrix. So right now we're kind of limited by the channel counts that we have, but the Falcon player and X-Lights are both committed to making changes to the software to allow the increased channel counts that we're going to need to be able to drive that projector or TV or monitor output as a regular matrix. When you're not playing a video, you'll be able to use that as just part of your regular display. So that could be a projector shining up on your garage. It could be a projector sitting out in your yard shining up on your whole house, and you can do a butterfly across the whole house. And if you use the whole house model, it would actually be in sync with your window frames and all the other pixels that you have on your house. So rather than having to put a grid of pixels up and down your walls, you could put a projector that has a fairly good light output on it, and just project something up on the house and sequence to that, if you didn't want to put video on it. When you do use this functionality, and I will be demoing it up here, when you do use this, it's treated just as a normal horizontal top left matrix. So it's the same way we treat these P10 panels that we've been demoing. We want it to be, we want the software to abstract the details behind the scenes so that you can just sequence to a horizontal matrix, and that's all you have to worry about is the size, is the start channel and the size. You don't have to worry about anything else, and the software will scale when it displays on the projector. It will scale automatically because if you're talking about a projector that's 1920 by 1080, can do Blu-ray resolution, then you're really talking about 2,000 pixels approximately by 1,000. So you're talking about over 2 million pixels, 6 million channels. You really don't want to sequence that much, because that means you're loading 6 megabytes per second, or sorry, 6 megabytes per frame times 20 frames per second. So now you're at 120 megabytes per second that you're having to read. So even though you have a projector that's doing 1920 by 1080, you're not going to want to sequence something that big. So we've already had discussions with Sean and Gil, and they've already got some ideas on how we can work with that and do some scaling and things. But you know, at least it will allow you to do something higher than what you can do even with these panels. This array up here is a 128 by 80, and so when I demo, I'm actually going to demo the same virtual resolution up here using the projector on the wall up here. Currently, using the current channel counts that are in the Falcon player, we can support about a 200 by 150 array. I haven't tested that, but that's just based on the maximum channel counts that we can support. You know, once you do the math, multiply by 3, etc. You know, we do plan on bumping that up, though. I'm gonna for the Falcon player that will be released in a few weeks, I'm gonna go ahead and bump the max channel count up to 500,000 or more to make sure that we can support these higher arrays once X-Lights can support, or your other sequencer that you use. As Sean, you know, if you sat in on Sean's class earlier, he did mention that the same projector that you're using for video, you could use as a virtual matrix when you're not using it for video. So we've had a lot of people question recently on the Falcon forums. They say, well, you know, I've got 10 sequences, but I only want to play video for 2 of them. How do I make the screen black for the other 8? And our answer was, it's not a problem. It's already black for the other 8. But if you are one of those people where you only have 2 sequences that you have video with, the other 8 sequences, you could be using the projector as a virtual matrix. And then when you do play a video on it, it will cover over the sequence data. So the sequence data doesn't show through the video. And as soon as the video is done showing, then the sequence data does show through. So as we get into more complex playlists, one of the enhancements that we're looking at for next year, it won't be around for this year either in 1.5 or 2.0, but one of the enhancements that we're looking at with the Falcon player next year is to make the playlist more of a scheduler or a sequencer, or if you go to sheet music almost, where the scheduler, because of the multi-master, the multi-sync ability that we have, we want to be able to look at a playlist and say, okay, right now during the playlist, I want to play this sequence. At 10 seconds into that sequence, I want to start this video on that host over there. At 30 seconds into the sequence, I want to start another video on that projector over there to shine on another part of my house. So it's almost as if the playlist is becoming a sequencer or a conductor for your house, for your show. So as we get into more complex things like that, we may be switching back and forth from using a projector for video and sequencing within the same song, potentially. So we wanted to allow that ability. One critical piece of that is if you are switching back and forth like that, the video, the bottom bullet point, the video that you're using and your virtual matrix have to be the same aspect ratio. So current TVs 16 by 9, you know, our old TVs 4 by 3. If you have a 4 by 3 video, but your virtual matrix is 16 by 9 because your projector is, then the sequence data is going to show through on those outside edges because the video doesn't cover up the whole sequence data. So if you're doing that, then you would not be wanting to sequence any data during the time when you're showing the video. You would just have to have it all black or not put anything in those cells at that time. I'll demo that in a few minutes. I'm going to walk through some things, and then I'll sit down and we can go through a demo for pretty much the second half and have questions as we go along. FPP Multi-sync, you know, I've covered that briefly a little bit. This is some of the questions came up yesterday. Is this cross-platform? It works with the Pi and the BeagleBone. Allows you to take as many Pis as you want, and I literally mean as many as you want, and connect them together. The limit is the current size of the internet, because we support broadcast. So if it is the size of your network, if it sends a broadcast out, if you use, you know, if you go into your router and you configure subnets, if you know what that means, your default home router comes configured for a /24 subnet, which supports 254 hosts. So just with your regular home router, you could have 254 Pis. If you reconfigure the network on it and go up a level, you could have 64,000. If you go up a level beyond that, you could have 64,000 times, another 256. So, it's virtually limitless when you want to talk about the number of pies or BeagleBones that you can connect together. It's just the complexity of your network will probably be the limitation, not the number of devices that you can connect. And those can be connected over wire or wireless. The sync packets, the master sends out, if you are getting into large networks like that, you definitely want to be using the all remotes option, which basically sends out a broadcast. If you only have a few systems that you're synchronizing together, then you can individually select those, and it will send one packet per host. So if you only have 5 servers, it's only sending 5 sync packets at a time. But if you have 10 or more, or even 5 or more, I would recommend using the all remotes option, which will send one broadcast packet out to the whole network. And then that's what allows us to go really big, because it's just one packet per second that it's sending out. This does allow synchronized sequences for distributed playback, so you can put that same sequence everywhere, which will allow you to have, and that's the way that we use the Falcon, the F16B controller, the F4B controller, and even the controllers where the Pi attaches to the back of the controller, because that way you can take your sequence and just copy it around, and you don't have to send that data over the network. It just plays locally. You can also have a different sequence on each one of the players, and each one of the player will play its own individual part of the show. And so in that case, you're actually sequencing multiple times in in whatever your chosen sequencer is, and then you upload those individual files to each one of the players, and then they play their own part of the show. So if you're synchronizing with a neighbor across the street or something, you might want to sequence their house separately to music, and then sequence your house to music, in order to keep the files smaller. So that's the second use. Third use is synchronized video. So we've had several users last year that synchronized multiple projectors at the same time. We've worked on patching the video player that's included with the Pi to allow us to adjust the speed of the video playback very, very finely, so that we can keep that video playback within one frame, which one frame of video is normally 29.9 milliseconds. So we can keep the video within one frame normally. Normally it stays in lockstep, but if it drifts out up or down a frame, we're pulling it back in to make sure that it's synchronized. So a lot of people use this for projecting from multiple places on their house, because one projector is either not optimal or they can't hit everywhere on their house at the same time from one projector. The master unit is the only one that needs to know about schedules and playlists. He's the one that needs to be able to talk to the internet to get the time, or if you have a real-time clock, he's the only one that needs that. When he starts playing a sequence, he sends a sync packet out to all the other remotes and says, you should be playing this sequence, and they start playing. And then every second he sends a sync packet that says, you should be here in the sequence, and if the remote is responsible for keeping himself in sync, and he will speed up or slow down to stay in sync with the master. If the remote reboots, it will automatically start back right up where it needs to be the next time it receives a sync packet, which again is once per second. If you miss a sync packet, if you've got a wireless connection between your house and the house across the street, and somebody turns the microwave on and messes it up for a few seconds, it won't stop playing. The remote player will continue running at the same speed that it was running at until it receives another sync packet, and then it will adjust if it needs to. So even if you miss a few packets, it's not going to stop the remote show. If you happen to miss the start packet that is starting the sequence, then the next packet that comes along, the remote will see that the master is already playing, and the remote will start right up where it needs to be and pull into sync. So, and it will seek to the right position. It won't even have to fast forward or anything. It actually seeks to the correct position in the sequence file and starts playing right where it needs to. I think I've covered most of the things here already. There are, I've covered all these actually in a little bit out of order. But again, there's virtually no limits to how big you can run a show with this. We've got several people that are running 8 or more Pis connected over wireless to go longer distances, and then several people that are just running multiple PIs in their yard so that they can not have to send all that channel data over E131, or because they're using one of the controllers where the PI or the BeagleBone attaches to the back of the controller. The next topic that we'll go over a little bit is the real-time pixel overlay. This allows you to directly manipulate channel data. Some of you may have seen the demo that I did of scrolling text across the matrix. So that's real-time. You can use that for SMS. You can use it for weather data, Christmas countdown. There's lots of things that you can put on there that you don't have to sequence. So because the text can be dynamic. So we've got a bunch of scripts that we've already written that you can just basically drop into place. You configure them a little bit to tell a little bit about your system, and you can immediately have a Christmas countdown running on your matrix to say, 5 days, 10 hours, and 3 minutes until Christmas, or 3 minutes and 10 seconds, and it'll just count down, and you never have to sequence that because it's dynamically updated. You have the ability to just take over the whole matrix or whatever you're overlaying onto, or to merge your whatever data you're putting on there with a background sequence. So if you are running something like that countdown, you could have a nutcracker effect, snowflakes running in the background, but then over top of that, you have an actual Christmas countdown running. Several uses, I've mentioned the texting, personalized messages. A lot of people use this to using the web interface from their mobile devices. They wrote people's names up on the matrix or displayed during their show. It also allows you to manually override show channels. So if you do have a channel that you wanted to, for some reason, turn on or force to a certain value, you can actually do that, and it will override all your sequences. So for some reason you might want to force on a one of the uses that some people use this for was they have a static tune 2 sign. It's basically just one channel of incandescence that they wanted to turn on at 8 o'clock. Rather than having to sequence that in every single sequence, they can put it on a channel at the beginning of the night, at the beginning of their playlist. They run a script which uses the real-time pixel overlay to turn on that one channel and force it to stay on. And then their show runs for 3 hours, and then at the very end of the night, they run another script, whether it's in the same playlist or not. It could be in your main playlist, or it could be a few minutes later. They run another script which turns that channel off, so that way they don't have to sequence their tune 2 sign to stay on in every single sequence. Or blow molds or inflatables or whatever you want to use it for. User scripts, so that's how people accomplish turning on those channels. So we have sample scripts for using the pixel overlay to go in and turn on certain channels. So the people that use this for the tune 2 sign basically just downloaded one of the sample scripts. They told it what channel they needed to turn on, and then they ran that. They set up a playlist to run that script, and it turned their tune 2 sign on. And then they took the same script, modified it, or they took the off version of that script. So there's an on version and an off version. They took the off version, they set it up for the channel, and they ran that at the end of the playlist to turn the channel off. We do have a script repository which has, I'll browse through that in a few minutes, and we can take a look at that just to walk through some of the samples or to list them out. We do have quite a few scripts that we've created or that users have created, and we've put into the repository that will make it easier for you to do things like that. Some of the other uses, we have people using this for projector control. Turn the projector on at the beginning of the night, turn it off at the end of the night. Interfacing with external systems, uploading a now playing update, now playing blurb to their Facebook site or web page, or even here's the playlist that's going to run tonight. Because they know what playlist is running, they can upload it dynamically, as well as starting and stopping playlists via external events. So next topic, FPP events. So we have the ability to trigger events based on user interaction or sequence-driven data. Yes. Did I not mention? Okay, sorry. So that's. Did I mention? Oh, I did mention that. So I have, this is not something that we've released. It's something that I've been playing with. I have the ability, and I did post a picture of this to the Falcon forum, where I've taken a webcam and connected it. So I currently have, this is a Raspberry Pi up here. I currently have this connected to so I've got a picture at home that I posted where I've got a Pi connected to an LED monitor at my house. I also have a webcam plugged into the Pi, and I have a program that I wrote that is capturing data from the webcam and displaying it on the virtual matrix that I talked about at the very beginning. So I'm using the LED monitor as a virtual matrix, and I have the webcam that is capturing data, showing it on the virtual matrix. So potentially, if you do have a matrix or a projector, there eventually will be the ability to run something, or to have a user come up and press a button and they can have their face up on your garage door, in the middle of a wreath even or something. So I'm trying to think up the ideas, and you can think up the uses. It's trying to advance the hobby. So speaking of that, pressing the button and having it take a picture and put my face up on the garage door, that's what you would use events for. So you have an event that is fired off when it gets an input from a GPIO trigger, and it runs a script which captures a video frame, which then copies that into the pixel overlay data, and it shows up on your garage door or your projector. So this data can be triggered by external events like GPIO, can be triggered through the web interface, can also be triggered by sequences. So we have control channels that we listen on, and you can trigger an event actually in your sequences. So if your sequence, if you had a sequence that wanted to turn off your inflatable, because for whatever reason, the Grinch inflates the inflatables, you could actually trigger something and have that done if you wanted to, if your inflatables were not controlled by a normal channel in your sequence data. So we support 576 unique events, just basically 24 major buckets, and each one of those has 24 minor buckets inside of it. And it does work with sequencers that support allowing you to specify 0 to 255 values as well as a percentage. Rather than using the raw values, we use a range to allow it to work with both kinds of sequencers. GPIO input-output, I think this is my last one. So both the Pi and the BeagleBone have lots of GPIO ports, general purpose I/O pins, basically. And I can attach just a very simple circuit with a couple resistors and a button to any one of those, and I can use that as an external input to the Pi to trigger events. To run scripts, to run sequences, to start a playlist, to do whatever I want it to do. So there are manual ways to do that with a couple resistors and a switch, or you can buy something like I have attached to this Pi, which is called a Pi Face. It has 8 digital inputs and 8 digital outputs, as well as 2 physical relays if you need to switch a higher load than what the digital output can switch. It also has 4 text buttons on it, which I'll use in a couple minutes to fire something off here. So are there any more questions? Otherwise I can dive into a demo of some of this stuff. Okay. First thing, virtual matrix. So this is going to continue projecting my laptop, which I will have the Falcon interface up on it. But then I've got this projector connected to the Pi on the HDMI output, and I'm treating that as a virtual matrix. So currently there is not a configuration UI, but I will have a config UI for the virtual matrix for the 1.5 release, which we'll have out in a few weeks. It's pretty trivial to make it. I just haven't got to it because I wasn't imagining how many people would be interested in it at this point. I'll step through the things in order that we talked about them, or I'll try to remember that order. So the virtual matrix, essentially, we sequenced yesterday This matrix right here, when we sequenced for the room in there, we threw together a test sequence that would treat the room as essentially a whole house model. And we took this array, and Sean was using it for several things. So I took the Pi and I connected it to an LED monitor that we had, and I took the data that was supposed to be displaying on the matrix here, on the P10 matrix, and I started showing it out the HDMI interface on the Pi. So that's that's the sequence that I have. Some of you may have seen this showing on the LED monitor that we had in the other room over there. Essentially, we're treating the HDMI output here as a 128 by 80 matrix. So you can sequence this. This is just a standard butterfly running line, and other sequences that we had for that array. But you can kind of see at this resolution, you can still see that it is a little bit blocky. So that's one of the reasons we want to bump up the resolution on this to give us higher resolution. Theoretically, we could potentially go up to a few hundred pixels by a few hundred. Probably realistically, at least right now, I think we'll have to look and see if we can optimize it to something even higher than that. But if you can at least get 400 by 300 out of it, that's 400 by 300. That's 120,000 pixels. If I did my math right. Yes, 4 zeros. So that's 360,000 channels. So you should be able to do that if we allow half a million channels. So with the, let me open back up here. So essentially, there's not really much to show about that. If you can imagine it being on a matrix, you can imagine it being on your projector. There's not really much to explain.
How does that get set up?
Pardon?
How does that get set up?
So there's really only 3 things to configure about this. So when I create, when I do add the setting for it, in fact it shows up in here right now, but I don't have all the config options. So when I do add the settings for this, underneath of the output config area right there, you'll basically have 2 more values, width and height, and that's all you need to set. So it will assume, it's going to require a horizontal top left matrix configuration in your sequencer, but the Falcon player is just going to need to know the start channel and the width and the height, and I will, it will automatically calculate the channel count, so you don't have to fill that in. So really, there's only 3 pieces of information: start channel, width, and height, and that's it. So it'll be really easy. You'll add it just like any other output on this page, where you go down and you select it. The name will change to virtual matrix probably, but you'll select the type, and then you'll just enter the start channel and the width and the height, and save it, and restart, and it'll be active. So you won't have to do anything with the just plug in a monitor. There's no underlying settings you have to change in the operating system. Multi-sync. So if you haven't played with multi-sync before, I've mentioned, I think, in several of the sessions that our goal is to make it so this is an appliance where you don't have to know about the underlying, what's going on underneath the hood. So we've tried to make multi-sync configuration as easy as that. So when you do want to use multiple systems, multiple players together, when you go into the multi-sync config screen, we actually discover all the other players on the network. So you can plug another player in. You don't even have to know its IP address. You can plug it in. You can, once it boots up, once you've installed it and it boots up, you come into this screen and it will have discovered that new player on here, and you can see its IP address. The system name here by default is FPP on every system, on every player, unless you go in and change it. If you do have multiple systems that you booted up without changing, it'll show up as FPP-1, FPP-2, because that's the way that multi-DNS works that we're using to do this discovery. If you want to get to one of those other systems to manage it, these are actually links here. So I can click on this BBB1, and open that up in another tab, and now I'm on the host, on that other, I'm managing that BeagleBone now, where I was managing the Pi. You can see the host name here in the top right corner, so that's another reason to rename your systems if you are using multiple systems. So once you have multiple systems set up, you go to this screen, you find them. We can see here that BBB1 is set up in player mode, so we can't actually control him because he's in player mode. BBB2 is set up as a remote. So if we convert this system to a master, we can then control BBB2 if we want to. So if you want to switch the current system that you're on to a master, you go to the status page. At the top it has FPP mode. Right now we're running in standalone mode. This is a standalone Pi. He's not controlling anybody. He's not being controlled. He's not in bridge mode. From here I can just change him to master mode. This will automatically go through and restart the daemon. And now if I go into the multi-sync page, I can now I'll have the ability to come in and I can either check all remotes to send a broadcast out to control all the remotes that are out there, or I can individually select remotes. And it'll warn me if I've already got all remotes checked, so I can uncheck that and I can select this BBB2 if he's the only one that I want to control, because the other ones are for testing or my yard light, my lawn border, yard pathway lights or something that I don't want to control.
What is bridge?
Bridge mode allows the Falcon player to act as an E131 bridge. So I can, just like you have a regular Ethernet bridge that bridges to DMX, the Falcon player can bridge from E131 to the P10 panels. It can bridge to the virtual matrix. Any output that the Falcon player has, it can bridge to. Even bridging from wireless to wired or wired to wireless, we don't really recommend that because you're not going to get that much throughput, but we support that for testing because some users have asked for it. So next topic here. So basically, when you do use multi-sync, you'll go into the multi-sync config screen. You'll pick the remotes, and then on each one of the remotes, you will have to go into the file manager and upload that sequence to the remotes. We don't currently have any method to sync those files around for you, although we are looking at it. So that's hopefully something we'll have next year. And I think that I changed the wrong one. So pixel overlay. Some of the scripts that we have here, which I'll go in and take a look at some of those. The pixel overlay basically allows, we take the channel data, I don't want to get too technical with it, but we take the channel data and we have a block of memory that we allow other programs to write to before we send that channel data out to the controllers. So that's what allows the webcam. It allows these scripts that scroll text across the matrix. It allows any number of programs to open a model and to write to the memory that's being used for that model, and it will then be sent out to the controllers. So if you are using a pixel overlay, you will need to go into the input-output setup here and create a pixel overlay model. So in here, I've created a couple samples here. I basically have told the Falcon player that I have a matrix out there. And so that's for this matrix that I have up here. I created a start channel of 1. I gave it the channel count. It's horizontal top left, because in order to scroll text across there, we have to understand the string layout of that matrix in order to be able to put the text and the pixels in the right place for the text. So we do have plans to import this data from Nutcracker, from X-Lights. So if you are using X-Lights as your sequencer to create models, you'll eventually be able to just take that data right out of there and put it in the Falcon player. You won't have to recreate those models inside of here. So once you have a model, you can test that out using the Matrix Tools plugin. Plugins are downloadable underneath the content setup underneath the plugins menu. We have a few plugins that are in there now. We will have more for the 1.5 version. But the Matrix Tools is one of those plugins. This tool will basically allow you to scroll text across the matrix or draw on it. I think I demoed this yesterday in the other one, the other session, so I won't spend a lot of time on it. But you know, I can come in here and I can type a message, and if I do everything correctly, this will scroll across the screen over there. If I did it correctly, but I might not because I didn't test that before. But this screen, once you create that model, this will let you go in and you know, this is what people used when they were standing out in the front yard and they were asking little Susie what her name was so they could show it up on the matrix on their door or wherever it was at. Was this interface? We also had people playing tic-tac-toe using the drawing. You know, I can come in here and you know, once this I can come in here and actually draw with my mouse or on a tablet with your finger. You can actually draw on the output.
It was working.
Yeah, I was working with that, yeah.
Oh, okay. It's on my screen because that matrix is so big. It's
real small.
I can, so here, make it green.
Was that under contents? That's
There you go.
under the desktop?
This is underneath of status control matrix tools. So that means the text probably did work. It just
It's so small.
it's yeah, I don't have the model set up correctly, but yeah, the text is actually scrolling off the bottom of the screen. That's why my mouse is zigzag there as well. But I think that the model that I set up is correct. But you know, you can, you know, I can sit here and move my mouse and it will draw a line on the screen where I move my mouse. Or if I'm on a tablet, I can sit there and draw with my finger. You know, we had people doing that, letting kids draw on their matrix or on their tree using this. So, you know, like I said, on the back end, we let any program write to that memory. So there are also lots of scripts that we created to do that. We have if you know anything about programming, we have a Perl library, Perl programming language. We have a Perl library which can be used to make it easier to write text and things like that. So we do have some sample scripts that are out there. Once I find it. Okay. So pixel overlay clock is one of them. Pixel overlay countdown is another. If I view one of these, this is the clock plugin. Basically, you come in, you just tell it what the name of your model is. You give it the color that you want. These are HTML colors. You know, it also takes words like red or blue, etc. You get a font name. So if you picked a font name that you like through the Matrix tools, you can type that name in here. Font size, center or scroll, whether you want it to scroll or give it an absolute position. Pixel number over 3 down 2, I want it to display right there. Scroll direction and scroll speed. So this is the clock one. So this is actually going to, this text that I have here it means that this is going to display a 2-digit hour, 2-digit minute, 2-digit second clock on the screen, and it actually is going to sit there and update once a second and just actually show a clock on your matrix. The countdown that we have does similar to that. And I'm not sure why that's not. So the countdown script basically does the same thing. It's got the same settings at the top of it, but this will display a message. You know, this particular one, which you can change the message. You can come in here and edit this text. This one will display Christmas countdown, and then the number of days, the number of hours, the number of minutes, the number of seconds, and it will update every second. So we had a couple users that had a big long sign out in front of their yard, and you know, they used to have this complex sequence that they had to substitute in things and everything, and now they just use this to display on a pixel-based matrix, and it would automatically update and count down for the whole month of December without having to update it ever. It would just keep running constantly.
Do we have the ability yet to put a countdown in between your shows? So you can say, you know, next show starts in 23 minutes, 20, 19 minutes?
That could be scripted.
Scripted.
Yeah, I mean, there are ways to do it. I mean, it's not something that we have a sample for.
Okay.
But
It's like-
yeah, I mean,
Cool
it's a
idea.
cool idea. Yeah, it would be pretty trivial, I think, to write something like that because we know when the next playlist is going to start because we can get that information.
Yep.
So it would be pretty easy to take this script and just modify it to get that, count that. Right now, basically, this comes in and just says, right here on this line right here, it basically just says, give me the amount of time it is from now until Christmas. And then it shows the difference. So it would be trivial to modify that for that purpose. So and there's other scripts that can be used for that as well. You know, what do I have, like 15 more minutes, I think? Since it's,
Yeah.
my clock is right here. So what we were just running was a sample of one of those user, or what we were just showing was a sample of one of those user scripts. There's a lot of other ones. That particular script, a lot of users that are using it as their countdown, they're running it all the time. So they're not really running it inside of a playlist. But there are other samples that we have for running inside of a playlist. We have several users that they've got the player, they have the FM transmitter up, but they're not using it for the other 11 months out of the year. They're using it for the month of December. So for the other 11 months out of the year, and even during the day for December, they wanted to take their transmitter and set it up as a in-house radio where they're playing music over it. So there's lots of applications that you can get that will allow you to stream music and control playlists and things like that. So we've got several users who are running that software, and we have a couple sample scripts here where they have their regular schedule, which runs their Christmas light show, but then they have another playlist schedule that runs one of these user scripts to start the MP3 streaming software so that during the day they have whole house radio using their FM transmitter. And then at night, 5 minutes before their show starts or an hour before their show starts, they turn that off and the FM transmitter is now ready to play the music and the videos that are played by the Falcon player.
You could schedule different scripts to go off here during your show.
You can,
Like, if you wanted to have a Christmas, countdown to Christmas for a little while, and then a little bit later during your show have something else.
yes, so yeah, inside of a playlist, so when you go into when you're creating a playlist, you can come in here and create, we don't let you run a script directly. You have to take that script and create an event out of it. And then inside of a playlist, you can run that event. You can trigger it. That script is executed what's called in the background.
Yeah.
So it doesn't pause the playlist at all. So you can make a script which plays a video. And the video will start playing and your playlist will continue on playing the next sequence. Or you can start the countdown script and it'll start the countdown on your matrix over here, and then your rest of your show can continue on. There's a bunch of other scripts in here. I basically downloaded the whole script repository from my laptop to walk through these. We've got sample scripts for turning GPIO on or off, so you can use that if you were trying to turn on that that tune to sign is connected to a relay on a 5-face, maybe, or there's lots of other things that you can do with that. We have scripts to go to the next playlist item or the previous playlist item. So you could actually have a button that lets people skip to the next song, or go backwards a song, or something like that if you wanted to, and that could trigger one of these scripts. We have the ability to remotely start a playlist. If you have a trigger in your yard, another button to let people start a playlist. Some people don't want their show running all the time. The viewers have to come up and press a button and it starts the show. You can use this to start a show locally on that player or on a remote player. Lots of different things. We have some users that want to switch their player between player mode and bridge mode at different times of the day. So they're, I can't remember the exact use case, but they were, at night they wanted the Falcon player to run the show, but during the day they wanted to be in bridge mode so they could test it with their sequencer. And they could just, from their sequencer, they could stream or send the E131 to the Falcon player and have it display. So they schedule playlists to trigger these sequences to switch the player between player and bridge mode. So that's a kind of a brief overview of the user scripts. Like I said, if you want to run a user script within a playlist, you have to create an event. So I've gone in here and I have created several events in here as demos. I created a start playlist event, a stop playlist event. Those run 2 different scripts. I created a start frozen video event and a stop video event. From this screen right here, once I created it, well, I'll show you how to add one first. If you want to add one, you click Add Event. You assign it an ID out of the list. You give it a name, and then you can pick an effect sequence or an event script to run, and then save it. And if I want to assign, if I want to create an event 1.3 for calling it a shutdown script, I can just click Save, and now I have this new event that I forgot the name, so I could come back in here and name it. And then I can just save it again, and now it's got the new name. From this screen, you can also test events. So I've got this event that will start a video on the projector over there. So I click Trigger Event and give it a few seconds. And it should work. It's not. And I tested that last night. So what that should have done is this, and started playing the video. But I may have messed it up when I brought it in from the other room. But you can, I have another script there to stop a video. And that's the one that everybody has to use for a demo right there. But so anyway, so you can create these events for whatever you want, and if you don't want one anymore, you can come in and delete it. And then once you have those, you can go in and create or use those inside of playlists. So GPIO, the Pi has, I think it's about 15 GPIO ports on it. I can count them on this other screen, but I don't want to do that. But effectively, there is a GPIO input screen. GPIO outputs, I'll talk about outputs first because it's pretty brief. GPIO outputs are basically another channel output. So if you want to control one of the GPIO pins on the Pi, all you do is add a GPIO channel output, and you give it the start channel that you want to use, and you pick the GPIO output number. And now you can control that GPIO output on the Pi with your sequence data. If you want to use GPIO inputs that are on the Pi, we allow you to set both rising and falling events. So a rising event is when the connection closes, and a falling event is when the connection opens. So if you put a infrared motion detector on there, or even some other switches, you might have a normally closed switch or a motion detector that when it detects motion, it opens the contacts, or you have a switch that opens the contacts, floor mat or whatever it is. So in those cases, if you're detecting a circuit opening, you would want to use the falling event. If you're detecting a circuit being closed or switch being closed, you would want to use the rising event. So since I'm using the Pi face, down here at the bottom of this GPIO config screen is the Pi face outputs. The Pi face has 8 inputs and 8 outputs. So I've actually hooked up the first 4 outputs to those 4 events that I created earlier. And since the Pi is normally open, or the Pi face is normally open switch contact, I've attached those to the rising events on there. There's nothing that prevents you from attaching both a rising and a falling for some reason. If you have a switch that, a mat that somebody's going to step on, and you want it to do something when they step on it, but they might stand there for 2 minutes, and then you want to do something else when they step off of it, you could set up individual triggers to happen when those occur. So
There's the Pi face is that extra board you buy to plug into the Pi, right?
yes, so there's a
How much current it currently supports, like 5 amps on 110 volts?
well, so for the GPIO, for the actual raw GPIO, you're looking at just a few hundred milliamps on those. The relays themselves are rated for 10 amps at 250 volts, it says, but I'm not sure if I would trust that. I don't think the trace on that board is big enough to hold 10 amps.
So you
But
could
you can run an amp or two at least.
At Halloween and do this and then turn stuff on with that little plug-in board.
Right, I got this because I want to, I'm not a welder, but I welded up a wireframe snowman and put lights on him. And one of my goals is to be able to have a snowball fight over my driveway where one of the snowmen throws a snowball and actually knocks the snowman down. So I have a contraption that I welded together where this snowman can actually fall over and stand back up. And I have a garage door opener, that sits off in the side. I haven't used this and I'm going to show you, but garage door opener sits off in the side behind the bushes, and it has a chain basically attached to the snowman. And when you press, when you activate the garage door opener, it'll stand the snowman up or lay the snowman down. So I wanted one of these to be able to trigger to connect across the input buttons on that garage door opener, so that I could just flip the relay and it would cause the snowman to stand up or fall down.
It's pretty amazing that little tiny box is running a motor.
Well, for that purpose, it's only, that's a low voltage connection. It's not handling the full load of the motor. But a lot of your, if you're using an SSR or a DLA Lynx Express or something like that, those aren't really rated to run motors. But if you can use something like this that has an actual relay on it, or we do also support, something that I added support for recently also is a USB relay board. So there are several places on the internet that you can get either a GPIO attached or a USB attached board that has 8 or 16 physical relays on it. So if you do want to control, blow molds or something else that right now you might have on a timer, you could actually hook those up to a physical relay to the Falcon player and control those with your regular sequence or with that pixel overlay that I talked about, where people run a script to turn on one of the channels and it controls the output on there. That way you can actually schedule that instead of relying on a timer that's plugged in, or multiple timers around the yard. So the Pi face will test this and see if it actually works. I think I did clear. Let me go back and clear the matrix tools first. So I turned this back to disabled, and it should have cleared. There are some optimizations I need to do as we have. When I created the pixel overlay code, we were looking at matrices a lot smaller than this, and within 6 months of having these, we now have something that we can go 3 times as big, or 9 times as many pixels, 3 times as big in each direction. So there are some scripting on the back end that there's some things that I want to do to optimize that to make it more efficient when you're dealing with larger displays. That's also one of the nice things about having the newer version of the Pi, which has about 6 times the horsepower. It's multi-threaded. The Falcon player is multi-threaded, which means it can be doing multiple things at the same time. When we're outputting out 5 different channel outputs, each one of those is happening in its own thread in order to try to make them all happen as fast as possible. So there is definite benefit if you're looking for a Pi to get the newer model, the V2 Pi, because it does have 4 processors, and each one of them individually is faster than the original Pi by a couple hundred megahertz. So I did hook up these GPIO inputs, and I should be able to go over here and get the first one, hopefully, and have it do something.
So is there a log page or anything like that would show what, like you just
show the buttons. So if you
show what
turn
just
on-
happened and what the Pi's trying to do?
Yeah, so we don't log, or we don't have that visible in the UI except through the log page. So if I were to go in, I won't do it because the log would get pretty long, but there is underneath of the file manager page, there is a logs tab. And inside of here are all the different log files from the system. So we have this FPPD log file, which is, this is the log file for the maintainment. So if I come in here and look at this, these are actually dating back to last year, some of these log entries. Also the time's not correct on here as well. But I can go back in and look at the logs. There is very fine-grained control over the logging that we have in here. So if I go into the settings screen, if you're having a problem with a channel output, you can actually come in here and turn on logging for just channel outputs. If I'm troubleshooting a GPIO issue, like this issue, I can turn on GPIO logging, set my warning level to, or set my log level to debug, and then this change happens real time. So the daemon will immediately adjust its log level, so you don't have to restart anything. You can come in here and just change something, and then go take a look at the log file. So since I like using myself as a guinea pig, we'll actually try this. I can go in here and view the FPPD log. If I scroll to the very bottom of it, or you know what? I'm going to take this file and I'm going to delete it. So that log file should get recreated, unless my USB drive went to read-only earlier, so that might be why it's messing up on me. I think it got corrupted when we pulled the power on it. No, okay, so log file, I deleted the log file and it got recreated. So I know that the only thing in there now is my data, and you can see from here that I triggered GPIO 200. So if I go back into the GPIO input screen and scroll down, here's that 200 number right there. So I can see that in the log that I actually got an input event, this is not running because of my sequence here. That's the wrong sequence.
So use number 3.
I should be able to, we'll look for punishment here. Let's try this. Let's see if this starts. No, that was broken earlier. But if I go into logs now again, I should see that I hit the second button, or the third button on there, which is GPIO 200. Yeah, so for 202. So, so you can turn on some logging and see what things are going on. If you got a problem with the channel output, you can go in there and look and make sure that it didn't complain that it was misconfigured or something. We try to fix those errors in the UI to not let you do things that are harmful, but you can adjust the log level yourself.
Thank you.
Basically, that's the end of what I was going to demo. If there's any more questions, I can take questions, or I think we're at our time.
I like to turn on off the power off all my controllers whenever this goes. And what do you suggest for doing that with this?
You could use something like one of those external relay boards and have your controllers attached to those relays. You still have to deal with the power supplies. I don't know if you turn the power supplies on. So your power supply is powering your lights and the controller. So your power supply is pulling a few hundred watts, a few amps. So you have to make sure that the relay board you were using was good enough to carry all that amperage, because that could add up quite quickly. There are also you can buy at you've seen them maybe at Walmart, Home Depot, Lowe's. You can buy other remote control receptacles, and some of them that you can buy, there are ways to control it over a network. And so we've got at least one user recently that bought a bunch of those, and he was working on making something where he could control those remote receptacles, and then he can plug in controllers or other things into those, so that you can turn those on and off remotely using the user script. Because those are designed to handle